So problem number 4 from your practice worksheet, which is actually, let me write this up here, it's actually 1969 AB19. Okay, so you should have that on your paper anyway. We're given that the velocity is ln of t over t. We're asked to find when the velocity becomes a maximum. So if you go back to the basics, when a f is at a max, f is a max when f prime changes from positive to negative at a critical point. Okay? So let's go ahead and put our v right here, okay, our v right there for f, and say v is a max when v prime changes from positive to negative. So we have to find v prime. That's our key. And most of the students who get this wrong, anybody who gets this wrong, just takes v because it's the derivative, and they get messed up because they don't go back to the basics. Okay, again, any function has a max when its derivative changes from positive to negative, and it's defined there, obviously. But here we see that v, we want to find where v has a maximum. Okay, and so we need to find v prime. All right, so v prime, by the way, the sucker answer would be 1. Okay, that's the sucker answer. Okay, because ln of 1 is 0, v would be 0 for t equals 1. But that's, I'm almost confident that's not going to be the answer, because that's when you just plug 1 in for t. All right, well anyway, v prime is equal to, this is the quotient of two functions. So we have the low multiplied by the derivative of ln of t, which is 1 over t. So low d high minus the high ln of t multiplied by the derivative of the low, derivative of t, which is just 1. Okay, all over the denominator squared, low squared. So we just get 1 minus ln of t all over t squared. Okay, keep in mind that our t value is greater than 0, so that's another thing to consider, because we're not going to have any critical points when t equals 0, because t can't be equal to 0. And the only way we can have a critical point here is that if v prime is equal to 0, because v prime always exists because t is always, again, greater than 0. So for all t values greater than 0, v prime does exist. So again, the only critical points are going to occur when v prime equals 0, and the only time that v prime is equal to 0 is when the numerator is equal to 0. Okay, so this is a tough problem because most students don't remember logs very well. And 1 minus ln of t equaling 0, meaning the numerator equaling 0, is only going to happen when 1 is equal to the ln of t, because I added ln of t to both sides. And ln of t is equal to 1. You can think of it any number of ways. You can convert it to exponential form. Any way you slice it, e to the first power is equal to t, because ln of e, sorry, I didn't mean t. Yeah, I did mean t. So e to the first power is equal to t, because ln of e is equal to 1. So t has to equal e. All right, so that's our only critical point, but now we need to make sure that that's going to yield a maximum. I'm almost convinced it is, because otherwise we're not going to have a maximum. But if we put 0 here and e here on our v prime test, so our v prime test, we're going to take a, let's say 1 is less than e. Remember, e is about 2.7. That will be good enough for now, 2.718. And when we plug in 1 into our v prime, remember this is our v prime over here, okay, and when we plug 1 in, we get 1 minus ln of 1 over 1. Well, ln of 1 is 0, and 1 over 1 is positive. So we can see that v prime is positive on the interval from 0 to e, and if we replace t with some other value, let's say ln of 10, let's say, so we have 1 minus ln of 10, and ln of 10, you should know that not that what it is, but that it's greater than 1. Okay, so ln of 10 being greater than 1 means that the numerator is going to be negative, and the denominator 10 squared is going to be a positive, or greater than 0. So we have a negative divided by a positive in our interval from e to infinity, and a negative divided by a positive obviously is a negative. So therefore, we see that v is increasing and then v is decreasing. And therefore, when t is equal to e, v has a maximum value. So there we go. C is the correct answer. There you go.